So for division of complex numbers, what we need to do is something very similar to rationalising the bottom of a fraction if you have surds, and it has been called, I've seen it in other books, called realising the denominator, so making it a real number. Essentially we just don't want to have an imaginary number underneath in a fraction. So in your notes I'd put your title, division of complex numbers, and what I'd be writing down there is that you need to make sure that you have no complex numbers on the bottom of a fraction. So we always want to try and eliminate, I suppose, eliminate complex numbers, or complex, or I should say not complex but imaginary parts from the denominator of a fraction. So I'll show you an example of that underneath. So for example, let's say that we had 3 over 1 plus 2i. Okay, now that's got a complex number underneath. Now what you'll see here in the notes is it says to take your complex number and to multiply the top and the bottom of the complex number by the complex conjugate of the denominator. Okay, so what we're going to do is we're going to multiply by the complex conjugate of the bottom, which is 1 minus 2i, over itself. Okay, 1 minus 2i. So let's expand that. We're going to have on the top line 3 times 1 is 3, 3 times minus 2 is minus 6i. On the bottom of the fraction we're going to have 1 times 1 is 1, 1 times minus 2i, 2i times 1 is plus 2i. So you can see the i's will cancel. And here we've got minus 4, because 2 times 2 is 4, I squared. Okay, now you may think at this point we haven't been able to get rid of all the i's, but the key thing to remember that important result that I squared equals negative 1. So we've got some cancellations here, but we're also going to be able to replace this I squared with negative 1. So I'll just continue in red. So we've got 3 minus 6i on the top. We've got 1, these are cancelled, minus 4 times negative 1, which equals 3 minus 6i on the top. And on the bottom, we've now got 1 minus 4 times minus 4, which is 1 plus 4, which is 5. So what you've actually done is you've taken something which originally looked like this and had a complex, an imaginary part underneath in the complex number, to being something that now has nothing, no imaginary part underneath. So this is sort of colloquially called, realising the denominator. The reason, you're making the denominator a real number. So instead of being an imaginary part, you're now making it into a real part. So we're going to do that up here with the examples we have. If you want to stop the video, you can try these yourself, but I'll show you how to get through them as well. So looking at I, we've got 1 over 3 minus 2i. We're going to multiply the top and the bottom by the complex conjugate. Remember that we're always multiplying by the complex conjugate only on itself. So we're going to get 3 plus 2i on the top. Underneath we'll have 3 times 3 is 9. We'll have plus 6i, minus 6i, and then we'd have minus 4i squared. So we'd have 3 plus 2i on top of 9, cancelling out your 6 i's, and we'd have minus 4. I replace the negative, the I squared with a negative 1 just so I can see what's happening, and then I can put my final answer, which is 3 plus 2i on 9 plus 4, which would be 13. Okay, so that's the first part. You might also, if you want to, split this up. It's completely fine to leave it like this. There are a couple of ways you could write this. So you could write this as 3 over 13 plus 2 over 13i. Or if you wanted to, you could also take the 1 over 13 outside of 3 plus 2i. They're all acceptable answers. Okay, this one is probably the more common one that you'll see in a textbook as an answer. All right. The next one, we've got I, 4 plus I. Essentially the same idea. You know, the only thing that changes when you're multiplying by the complex conjugate, if you have something a bit more complicated on the top line, just gives you a bit more work to do. So just keep track of the multiplication that you have to do, okay, which is with each term, okay, with each other term on the top. So we've got 12 plus 8i plus 3i, and you know, I just do this when I'm actually working it too, like I actually just show myself on the page so I can see what I'm multiplying together, and it helps you just not to make mistakes. 9 plus 6i minus 6i minus 4i squared. And the thing to look for as well is, you know, you've done the right thing if your answer doesn't have any i's on the bottom line. Okay, you're going to combine the things that are similar on the top, and you're going to replace the I squareds with negative ones in here. Okay, so we've got 12, 8 plus 3 is 11i, plus 2 times negative 1 over 9, and we've got minus 4 times negative 1. So our final answer would be 12. This is going to be take away 2 here, so 12 take away 2 is 10, plus 11i over 9, and this will be plus 4, so over 13. And if you want to write it in that sort of more common way, you just split it up into the two parts there for I. Okay. The next one, which is B, what we're doing with this one is a little bit more complicated. Essentially, we'll start off. It's essentially the same idea though. So we've got 1 plus 2i squared, and we've got I, 1 plus 3i. Okay, it's a good idea to first of all expand what you have there so you can see what you're working with. So I'm going to expand this because then I can actually see what the complex conjugate is more easily. Okay, so expanding the top line. Often if you have trouble expanding in your head, write out the top line, you know, it's a squared, but write out the two brackets. Here I can see I've got I times 1 plus 3i squared. Okay, and then again I'm going to do 1 plus 2i plus 2i plus 4i squared on the top, replacing my I squared with a negative 1. Okay, combining things together. So again, here combining the like terms, and this is going to turn into a negative 1. So we've got 1 plus 4i plus 4. You don't need to have all these steps of working. You know, I'm just putting all the sort of possible steps you can have. 1 minus 4. Okay, you're going to have minus 3 plus 4i over, and it's really a good form to write your real part first and then your imaginary part. So we haven't even done anything yet. All we've done is we've just expanded and simplified it a bit. So now we can realise the denominator, and we're going to just take what we have and multiply by the complex conjugate. Remember, always the complex conjugate. The reason for that, remember that in the work at the video at the start of this section, the complex conjugate, when it's multiplied by the original number, is going to give you a real number. And you may have noticed as well, as we've been going, that you could skip this whole step of multiplying with the complex conjugate on the bottom. You'll have to still on the top, by realising, remember that z times z bar equals a squared plus b squared, or it equals the magnitude of z squared. So you could really just look at, say for example here, the first term, the real term, square it, which is 9, and the second term, which is 4, or negative 4, square it, okay, or negative 2, square it, which is 4, and add them together. That's what you end up doing, you see. So we're really going, we know at this point we're going to be taking 3, squaring it to get 9, and then squaring 1 to get 1. So we'll end up with 10 on the bottom here. Okay, so you can do it shorthand. You can straight up just know you'll get 10 on the bottom here and just write 10, and then just work through the top working out. I'm just going to do the whole thing just because I'm here. So 12i minus 4i squared, and you've got 9 plus 3i minus 3i minus i squared, and you can see here the 10 is going to come in. So combining things again, because you've got 3 minus 12, that's minus 9. So we've got 9 minus 9i minus 4, replacing the I squareds with a negative 1. Okay, and 9, here we've got minus negative 1, which gives us the 10. So we're going to have 9 plus 4, which is 13, minus 9i on 9 plus 1, which is 10. So it's what we expected to get 10 on the bottom. Remember the real part squared, which is 9, plus the imaginary part squared, which was 1. So that would be 10. So you're getting what you're expecting from that. So that's the idea when you're multiplying or dividing, I should say, complex numbers. Always make sure that you're realising the denominator, so making sure that you get rid of any imaginary parts on the denominator by multiplying the top and the bottom of your fraction by the complex conjugate z bar.